We have understood through our earlier videos the importance of lean management. If an organization implements lean management, it can minimum double its productivity and double its profit. That is the power of lean management. Even global companies have realized the benefit that their performance improved by another 80% by using the lean management concept. For implementing lean management concept, one of the most important tool to know is value stream mapping. The objective of this session is to make learning of value stream mapping simpler and to help individual to easily apply this concept in the respective areas, be it business or organization, say in manufacturing or service sectors. Hi, this is Jagdish Kumar doing this presentation for you. To begin with, let us know the wastes which we should eliminate in lean management. They are unnecessary transport, because do not ignore transport cost. Transport cost can be huge portion of your expenditure in manufacturing. Please remember this. Inventory, which is excess. As we know, excess inventory leads to money being locked up, space being occupied, extra effort to maintain the item, and if the item is a shelf life item, the entire item becomes waste post shelf life. Unnecessary motion on the workbench, whatever unnecessary actions I do becomes a waste. For example, if I have multiple types of screws used in the assembly, I need to use multiple screwdrivers. It will take a very long time to do the assembly. Instead, if I can standardize all the different types of screws into one and use one screwdriver, unnecessary motion on the work table is eliminated and assembly becomes faster and smoother. Waiting is a waste in business. Let us remember, time is money. Any waiting that happens leads to loss of money. It's a waste. Overproduction is a waste, because the item that is produced more than 20% of demand may become non-saleable, obsolete, or out of demand in the market. Then the entire capital becomes a waste and a huge loss for the company. Over-processing is a waste. Instead of doing one-time cleaning, suppose as the company standard says I do 3 times cleaning, where one-time cleaning with acid would have been enough. This becomes unnecessary processing. We should minimize, streamline the process, validate the output to just meet the requirement, and then use that simple process. Defects are a waste, because defect repair, whatever is done, requires resources like time, labor, and materials, which will never be paid by customers. And if the defect becomes a scrap, the entire item has to be discarded. There is a memory tag to remember these 7 ways called teamwork. And the 8th one is unused talent, which is rampant in India. People make the organization. If the organization can tap the talents of the people who are innovative, that organization can make a marked difference. In India, we have a lot of youngsters with ideas, but no means of channelizing them. Then obviously it becomes underutilized or unutilized. Unused talent, which also is a waste. Now in lean management, as we understood, we work constantly to eliminate these wastes to enhance our productivity, at least to double. Now I will start with an example so that the value stream mapping is comfortable for us. Value stream mapping, to start with, is nothing but a flow chart. Flow chart is one where the process steps are written in rectangular blocks connected by the arrow moving from operation 1 to 2, 2 to 3, 3 to 4, and so on. Now you can see a ladder diagram below, which is added parameter and the salient feature of value stream mapping. Here, under machining, 30 minutes are written. That means machining takes 30 minutes. In between machining and the second operation, deburring, 5 days become the waiting time or transport time, say. Assume it as waiting or idling time. Then again, 10 minutes below deburring means 10 minutes are required to do the deburring operation. Again, between deburring and crimping, 3 days of waiting. Under crimping, 5 minutes. That means the crimping process takes 5 minutes. 7 days of waiting between crimping and testing, and finally 90 minutes for testing before item becomes accepted. Now the ladder diagram has a top crest like 30 minutes plus 10 minutes plus 5 minutes plus 90 minutes. which become 135 minutes, and this time is called as value added, which in terms of number of days becomes 0.1. If you look at the bottom of the ladder, 5 days plus 3 days plus 7 days add to 15 days. These are the non-value added time, because as we learned, waiting is a waste. Now please remember from global parlance these words. Lead time here means value added time plus non-value added time. That means 15 days plus 135 minutes. 135 minutes being 0.1 day. Lead time now total becomes 15.1 days. Now coming to cycle time is that value added time used on the operations, like 30 plus 10 plus 5 plus 90 minutes, which become 135 minutes or 0.1 day. Now you see the surprise. Process efficiency is given by value added time, because that is the real time spent on production, divided by value added plus non-value added time, the waste added at the denominator. In short, it can be remembered as cycle time divided by lead time is equal to 0.1 divided by 15.1, as you can see here, is equal to 0.6% only. Look how, if we are not alert, your process efficiency is so low. You are only 0.6% efficient in this particular live case. Definitely there will be opportunity for you to increase it to 84% by eliminating or reducing the non-value added time when there is a huge customer demand for the particular product. This is value stream mapping. So as we understood, value stream mapping is nothing but the flow chart with additional information. Here, since time is a factor, time is used, value added time and non-value added time. Also you can use cost. For example, machining may cost 7,000 rupees, deburring 1,000 rupees, crimping 500 rupees, testing say another 4,000 rupees. Definitely when you write in terms of money, you should start minimizing the cost for the highest cost item or process, that is machining. Machining, why you should start questioning now, why it should cost 7,000, why not half of that? Generally you keep 50% as our future state or target, and then work towards it to remove those non-valued motions and activities happening during machining or unnecessary steps you are doing during machining. For example, in one case, in my experience, we used 3 tools to do the machining. Instead of that, we combined all the 3 and made one. Now you can visualize how much of time is saved and how 3 operations happen in one setting. Next, after improving machine, you look for the next high cost process, as I told, testing, which costs 6,000. Why 6,000? Why not 3,000? You can use AT, automatic test equipment, and so on, or train the operator, or simplify the SOPs, so that standard operating procedures, so that you can do it faster, say in 45 minutes. So we can use the time as the value stream mapping parameter, cost. We can also use the time delay, whatever is seen here when there is an urgency. You can consider longest time consuming process as a bottleneck and remove the bottleneck by outsourcing some portion of the job or some portion of the particular process, and then getting it done parallelly done outside and reduce and increase the throughput, or if it is not possible, enhance our own in-house facility. So value stream mapping can compare time delay, it can compare cost, it can compare quality parameters like yield also. If the machining yield is only 80%, testing is 100% definitely. Now I look for why 80% yield in machining, why not improve? What can be done? And please remember, simple actions like improved jig, improved training, improved facility, better raw material can improve your quality performance by miles. This is how value stream mapping is and how it is used. Now, what does value stream mapping compares or considers? We can now clearly say it considers cycle time. The cycle time should be reduced. Cycle time is nothing but value added. What should be totally tremendously reduced is non-value added time, which when added to value added time, it becomes the lead time. In other words, you should minimize cycle time, optimize rather, and minimize lead time also. The process efficiency goes up. Also, as I mentioned, wherever yield is less, quality impacting operation, you should start focusing and make actions to improve. Balancing line, as I told, removing the bottlenecks is also one of the metric or measure that can be improved using the value stream mapping. Value stream mapping is very useful in standard work. Many people think standard work means SOP. It is not just SOP. It is is an optimum combination of man, machine, material and method, including technology. So if you standardize work, if you go for standard work with all optimization, it will bring down cost, it will bring down time, your throughput increases, it improves your technology, it improves the skill set of the people, making the work easier for them to. Now, why VSM? VSM helps in understanding information flow. Information can flow from operation 1 to operation 2 to 3 to 4, or information flow can flow in the reverse direction, operation 4 to operation 3, operation 3 to operation 2, operation 2 to operation 1 in the reverse direction. For example, if the organization has just-in-time or Kanban, the operation 4 person says operation 3 person, how many balance numbers only he has to deliver, how many numbers he has already got out of the day's target. So information can flow forward as well as reverse. Whereas material flows in the forward direction from operation 1 to operation 2, then onwards to 3 to 4 and so on. The value stream mapping clearly shows how the information flows and how the material flows. Also, value stream mapping is a very important tool and very easy tool to use to identify the waste in the process, which can be low yield, which can be high cost, which can be high time delay. Remove the debottleneck or do the debottleneck. This is what is the topmost advantage, which is actually there recommended by Goldratt in theory of to improve. Going forward, these are the measures in VSM that we should know. Inventory turnover ratio. Inventory turnover ratio here means cost of goods sold or what net sales you have done divided by average inventory. Means to say your average inventory should be worth as less days as possible. If you keep longer days inventory, number of times it gets rotated in a year becomes less. Your inventory turnover ratio also becomes a smaller figure, which is not desirable. Inventory turnover ratio should be as high as possible. Means to say with the minimum inventory you should be able to do maximum number of rotations per year in terms of acquiring order up to money realization. The second metric is cycle time, which is nothing but value added time. This is a useful time, but this can be optimized further by questioning why and removing unnecessary motions and so on. Minimize cycle time, your process becomes more efficient and your throughput also becomes high. Lead time, as we understood, is value added time plus non-value added time, and non-value added time will be enormously high if you have not attended to the process through value stream mapping to improve. This put together is lead time, and lead time has to be minimized. Then only process efficiency goes up. Further measures here are uptime, means the actual operation you have done divided by available time. For example, I can run the machine for 3 shifts. I am only using in 1 shift. That means my uptime is only 0.33 or 33%, which is very poor. If I make 2 shift working, it becomes 66. If I make it 3 shift working, it becomes 100%. And there is a demand. Takt time is time available for production. It can be calculated like this. For example, in a given for a machine, we can operate for 300 days, 365 minus holidays, 300 days. If the customer demand is 100, then takt time becomes 300 by 100. That means in a continuous flow, in a linear production, every 3 days, one item should roll out. Now the challenge comes. Suppose customer says my demand is 200. What number of days available will be only 300. 300 divided by 200 becomes 1.5. Every 1.5 days, item should roll out, which is not possible straight away. What will you do? Customer's takt time, you should respect. Your takt time may be 3 days. Customer's takt time is 1.5 days. Means faster rate item has to roll out. You need to now explore means of outsourcing and getting it done parallelly. If not, build facility or capability enhancement in-house. Takt time is a very good measure in VSM to ensure that you can deliver, and customers ask for takt time to get assurance. Yes, throughout the year I will not be let down by this supplier. He will be able to deliver the goods at the speed, takt time speed that is required. These are the major steps as we saw now in value stream mapping. First, choose the value stream. Choose that process which is very critical. Choose that process which is highly important for the organization, and then draw the process flowchart in detail. You may be already having the SOP, that means flowchart may be already available. Now this becomes your current state where you need to make entries on what is the time taken for each process step, and also what is the actually money that you need to spend so that high cost process steps can be attacked. What is the process step where your yield is much poor, so that you increase the yield, where you have the bottleneck so that you can remove the bottleneck and improve the production. So this is important. Then you identify the lean metric. What you want to improve? You want to reduce the cost, you want to reduce the delay, you want to do the debottlenecking, you want to increase the yield at the place where the yield is very poor. You should decide. Then create the future state map. Here one of the global companies says imagination at work. Do not think how what you want, you map down. For example, I had a practical case where the process steps were 21. Finally we dreamt of 6 steps, but without jugglery we could manage with the 7 steps. And look at the benefit now, 21 step versus 7 step, how fast the production happens, how the quality improves, and how comfortable it is for the organization. So strive to achieve the planned future state. You may not reach the target, but if you reach nearer to the target, your job is done. Please subscribe to this channel if you have not subscribed so far. And as we know, quality is a journey, ongoing journey. There is no end to it, and lean tool is your real friend who can help you to achieve this quality, cost reduction, then higher productivity, and thereby higher satisfaction too. Thank you so much for all your